Hello students, welcome to CATCH25 Academy. Let us now start our next set of questions based on the topic Newton's laws of motion with friction. So we are doing questions from our class notes. So let us see question number 14. So the next question we have is question 14 on page 14 as well. So illustration 14 at page 14, we are given a block of mass m, which is placed on an inclined plane. So this is the inclined plane. And we have a block whose mass is capital M. Here the coefficient of friction is given as 0.5. So in this case, we have to find the acceleration of the block when it is released. This is the first part of the question. So let us first solve the first part. So one force is mg. Another force is mg sine 37 and mg cos 37. These are the components of mg. Then we have normal reaction N, friction force F in backward direction, acceleration A in down the inclined direction. So along vertical direction, we have normal reaction is mg cos 37. Along horizontal direction, down the incline, we have big force minus small force is mass into acceleration. So big force in this case is in the direction of acceleration, which is mg sine 37 minus small force whose value is friction force is equal to mass into acceleration. So these are the two equations. Now we can write friction force as mu n because there is acceleration, so it is kinetic friction, its value is constant, so mu into n. Let us substitute the value of n as mg cos 37. So our equation will become mg sine 37 minus mu mg cos 37 is equal to ma. M cancels on all sides, both sides, M cancels. So acceleration comes out to be g sine 37 minus mu g cos 37. So this is our answer to this question. Just we need to do the calculation. So g is 10, sine 37 3 by 5 minus mu is 0.5, g is 10, let us say cos 37 is 4 by 5. So upon solving, we'll get the value of acceleration. It will come out to be the answer to this question. Then let us go to second part of the question. In the second part of the question, we have a force which is applied on the block as shown. So we have a force which is 75 Newton up the incline. So in that case, find the acceleration if the block is initially at rest. So let us first find the maximum value of static friction. So maximum value of static friction is mu Sn, which is 0.5 into mg cos 37. So let us calculate this value. So mu s into n, it will come out to be on calculation 40 Newton. So maximum value of static friction comes out to be 40 Newton. So this is the maximum value of static friction if at all required. Okay. Mg sine 37. Let us calculate the value of mg sine 37. So m in this question is given as 10 kg. So 10 into 10 into 3 by 5. So we will have 60. So mg sine 37 will be 60. So let us write some values. Mg sine 37 is 60 Newton. Friction force, static friction maximum value is 40 Newton. And we have the maximum applied force. The applied force is 75 Newton. So let us think how to solve this question now. So in this question, we have a force which is 75 Newton. In what direction we have to find the acceleration. So in this case, let us try to find the higher force. So what is the value of higher force? So in this case, we will have one force which is static friction whose maximum value is 40 Newton, mg sine 37 which is 60. So let us mark these forces. So one is 60 Newton in down the inclined direction. Then we have another force which is static friction and 75 Newton, which is the applied force. So due to this, the tendency of motion will be in upward direction, but there will be static friction in downward direction. And if this static friction is 15 Newton, then 75, and here also we have 75. So the block will have no acceleration. So in that case, we can say the block will have no acceleration. Applied force is 75 Newton and 60 Newton is downward force. So static friction, it can act up to 40 Newton. So only 15 Newton is required to stop this body here. So in that case, we can say acceleration in second case will be 0. Now, after this, let us go on to next question, C part of the same question. So in the C part of the same question, we have, if in case 2, how much force should be added to 75 so that the block starts moving in up the inclined direction. So this is our diagram. So we have 60 Newton, which is mg sine 37. And another force, which is in this case, the friction. So maximum value of static friction will come out to be 40 Newton. Now we have to find the value of applied force so that motion just starts. So F in this case will be 60 plus 40, which is 100 Newton. So once we have the applied force of 100 Newton, the block will start moving in upward direction. So in that case, we can say how much force should be applied. So already we have 75 Newton force. So we should apply a further of 25 Newton so as to make it 100 Newton in upward direction, so that the motion of the block starts in upward direction. Finally, in the fourth part of the question, D part, what is the minimum force by which 75 should be replaced so that the block does not move? So block, we don't have to move in this case. So this is 60 mg sine 37. And friction maximum value is 40, but it is static friction, so it can be 0 as well. From 0 to 40 it will have. And we have applied force, let us say 60 Newton. So 60 balances 60. In that case, static friction is 0. So in that case, we can say answer to fourth part of the question, it will come out to be in this case 60 Newton. So to make this force 60 Newton, we will take the help of static friction. So static friction in this case will act in which direction? The tendency of the block is to move in down the inclined direction. The tendency of the block is to move in down the inclined direction. So the block is trying to move down the incline. Now, if the upward force is 60 Newton, downward force is 60, upward force, if it becomes 60, then this block will not move. So in that case, because the tendency of motion is in downward direction, we can say this is not the acceleration, this is the tendency of motion. So tendency of motion is to move down. So we can apply static friction maximum value, which is 40 Newton. So upward force will applied force will be 20 Newton, because 40 plus 20 is 60 and 60 in downward direction. So 60 balances 60. So the applied force value will be just 20 Newton. Overall, the upward force will be 60 Newton, because this is comprising of applied force and friction force. So that is how we'll calculate this. So this is how we calculate this question number 14. So let us now move on to next question, question 15. So in question 15 on page number 18, we are given question 15 on page 18, illustration 15. We have to find the acceleration of the block. So we have a 10 kg block here, and this 10 kg block, we have to find its acceleration. We are applying upward force of 75 Newton. This angle is again 37 degree, and this is a fixed wedge. This is fixed. That means it is fixed to ground. Angle is 37. The coefficient of friction, it is given to us as 0.5. Now we have to find the acceleration of the block. So acceleration of block, let us think about the forces. One is 10g. So the component will be 10g cos 37 here and 10g sin 37 here. Normal reaction in the upward direction. Then friction acts up the inclined direction. So in this case, what do we have to find? We have to find the acceleration of the block A down the inclined direction. So in that case, what are the forces? So minimum, in this case, we will have maximum resisting force. So what is the maximum resisting force? So what do we mean by resisting force first? So friction maximum value, we calculate it is mu s into n. Mu s is 0.5 into normal reaction is 10 g cos 37. So on calculation, this will come out to be 0.5 into 10 into g cos 37, which is nothing but 40 Newton. Now, in this case, 40 Newton is acting. So 75 Newton guaranteed acts up the incline because that is the applied force in up the incline direction. 60 Newton acts guaranteed because in downward direction because that is the component of mg. Now let us think about the tendency of motion. Tendency of motion in this case is upward direction because 75 Newton is applied in upward direction. So friction will act in opposite direction. So in this case, friction acts in opposite direction. So in that case, we can say the downward friction which will act is 15 Newton. That will balance the 75 because 60 plus 15 is 75. So 75 in up direction, 75 in down direction, that is balanced, leading to zero acceleration. So we can say the friction in this case which is acting is 50 Newton and acceleration in this case is 0. So this is the answer to question number 15. There is no motion. Friction is 15 Newton. Then let us move on to next question, which is 16th question. So in 16th question, we have to find the distance traveled by the block. There is a block here. Let me draw a better horizontal line. The block has mass 10 kg. It is moving with 10 meter per second with respect to ground. We have to find the distance traveled by the block before it stops. That means final velocity is 0. So let us see how to solve this question. Initial velocity in this case is given as 10 meter per second. Let us find the value of friction. So friction in this case, first force is mg downward direction, which is 10g, which is 100 Newton. Normal reaction is also balanced. It is 100 Newton because downward force is upward force. So then we have in that case friction force, which is in backward direction. Friction in this case will be mu n. So the retarding force here, the retardation in this case will be friction force upon normal reaction. So friction force in this case, it comes out to be mu n upon friction is mu n, and upon we have force is mass into acceleration. So in denominator we will have mass because friction force is mass into acceleration. Mu n is mass into acceleration. That is the equation. So upon mass, so mu into, in this case we have which force, normal reaction is mg. So normal reaction here is mg. Upon mass is m, so mm cancels. So retardation is minus mu g. Why negative? Because in this case, acceleration and velocity are opposite direction. In this case, the applied force, friction force is in backward direction and velocity is in forward direction. So they are in opposite direction. That means in this case, what will happen? Acceleration will be minus mu g. So that is how we have this value minus mu g. So once we have this acceleration as minus mu g, let us do calculation of the value of this minus mu g. So what is the value of mu given in this question? In this question, we are given mu as 0.5. So 0.5 into mg, which is 100. So 50 Newton. So friction force comes out to be 50 Newton. So acceleration is minus mu g, which is minus 0.5 into g, minus 5 meter per second square. So which equation will we use? V square is u square plus 2as. So s is equal to v square minus u square upon 2a. So v square in this case is 0, minus u square is 100 upon 2 into acceleration. Acceleration is minus 5. So minus 100 upon minus 10, which is 10. So displacement in this case comes out to be 10 meter. So we can say the answer to displacement here is 10 meter. Is the answer to this question. So let us move on to next question after this. The next question after this will be question number 16. So question number 16 is what we solved. So let us move on to next question, question number 17. So in question 17, we have a same kind of situation. We have a block which is having a mass, let us say m, and this angle here is 37. Mu is the coefficient of friction, which is given as 0.5. Initial velocity of block is 10 meter per second up the incline. So u is 10 meter per second. We have to find the distance traveled before it stops. That means final velocity is 0. So final velocity in this case will come out to be 0 meter per second. And deceleration we have to find out. Displacement we have to calculate. So let us think about the forces. Of course, one force in this is mg sine 37. There is another force which is mu mg cos 37. Because here we have normal reaction n. This is mg cos 37. Now, in this case, we have acceleration, which will be retardation. Actually, acceleration will be in downward direction. Retardation will be in upward direction. So, in this case, we have mg sine 37, which is the downward force, minus mu mg cos 37. That equals mass into acceleration. Mass cancels out. So deceleration in this case comes out to be g sine 37 minus mu g cos 37. This is the value of deceleration. Because it is deceleration, let us put a negative sign here, minus sign. So let us find the value of this deceleration. G, which is 10 into sine 37, which is 3 by 5, minus of minus plus mu, which is in this case 0.5, into G, which is 10 into cos 37, which is 4 by 5. So here we get 6, and we get this value here 4, so minus 2. So in this case, the retardation comes out to be minus 2. So let us first think about this retardation once again. G sine 37 minus mu g cos 37. So in this case, what are the given facts? Let us think about the forces. One force here is, because the motion is in upward direction, friction has to be in downward direction in this case. The motion of the block is in upward direction. So we have to mark this friction force in down the inclined direction. So let us do that correction. So because the tendency of motion is in upward direction, we will mark the friction force in down the inclined direction. So friction force acts down the incline. So our equation here will be changing. So what will be the equation? So in this case, we have mg sine 37 plus mu1. That equals ma, because acceleration is in downward direction, retardation is in upward direction. So mg sine 37 plus mu into mg cos 37, because normal reaction is mg cos 37. So that equals ma. M cancels on both sides. So acceleration value comes out to be g sine 37 plus mu g cos 37. So if we substitute the value of g sine 37, mu, again g and cos 37, we'll find that the acceleration comes out to be 10 meter per second down the incline. So retardation will be minus 10 up the incline. So we have just found the value of retardation. It comes out to be minus 10. Let us now use kinematic equation. V square is u square plus 2as. So s comes out to be v square minus u square upon 2a. So what is the value of v square is 0. Minus u square is 10 square, which is 100, upon 2 into acceleration or retardation, which is minus 10. So displacement on solving, it will come out to be 5 meter. So the correct answer to this question, displacement comes out to be 5 meter before the block stops. Now, after this, let us move on to question number 18. So illustration 18 of our book. So in this case, we have inclined plane. It is a smooth inclined plane in first case. And we have a block here. It has to come down all the way to displacement S. In second case, we have a rough inclined plane. The same length of inclined plane, but it is rough in this case. The same type of block we have once more. It is again released from the top like this. And it covers the same displacement, which is S. So displacement is S. So this is rough wedge, rough inclined plane. So in this case, it is given that time required here is n times t. If the time required to come down here is t, here we have time which is nt. So here n times more time is required. We have to find the coefficient of friction in this case. So let us think how to solve this question. Let us use the acceleration. Initial velocity in both cases is 0. Then we have displacement in both cases is same. Acceleration in case is g sine theta. Here acceleration is, so we have the forces as we see. G sine theta, friction will be upward. So g sine theta minus mu g cos theta. We have done this in previous cases. So we will have mu n as the friction, mg sine theta force downward direction, mg cos 37 perpendicular to the incline, normal reaction up the incline. So these are the forces acting. Based on that, we can calculate the acceleration down the incline. As we calculated in previous questions, it is g sine theta minus mu g cos theta. Time here is t, time here is nt. So which equation will we use? We will use S is ut plus half t square. Let us use this kinematic equation S is ut plus half t square in both cases. First in case of smooth wedge, and then in case of rough wedge. So using the same equation both sides. So S, this comes out to be u0 plus half a. Acceleration in this case is g sine theta into t square. And here we have S is u is again 0, half into acceleration is g sine theta minus mu g cos theta. The whole into t n square t square, because t here is nt. So nt means n square t square. Now because the displacement in both cases is same, let us do the equating the displacements. So half g sine theta into t square, the RHS of this side equals half g sine theta minus mu g cos theta into n square t square. T square cancels on both sides, half cancels on both sides. So g sine theta is equal to g sine theta minus mu g cos theta bracket n square, because t square has cancelled out. So from this now next let us calculate, cancel g on both sides. If I take g common and cancel on both sides, I will get sine theta is equal to sine theta n square minus mu n square cos theta. So from this mu comes out to be, if I take this term on this side, this term on this side, so we have so here we will have sine theta common on the RHS, n square minus 1 upon we will have n square cos theta. So something like this. So this will be the value of mu. Tan theta bracket 1 minus 1 upon n square. So our answer to this comes out to be mu is tan theta bracket 1 minus 1 upon n square. This is the answer to question number 18. Now let us move on to next question, which is question number 19. So on page 20, we have illustration 19. Now, in this, we are given a block on an inclined plane. We have two blocks, so A and B having angle of inclination of 27 degree given to us. So blocks are each 1 kg. The coefficient of kinetic friction is mu k, which is 0.5. At time 0, the block A is released, but block B is projected up. So this goes up, this goes down. The coefficient of friction is 0.5. So this block is released with initial velocity 0. This block has initial velocity 10 meter per second in up the inclined direction. Initial separation is given to us as 6 meter. Find the distance from point A where they will collide. So we have to find the distance at which they will collide. So let us see how to solve this question. So in this case, let us draw the free body diagram of B. So of course on B we have one force which is mg sine 37 downward direction. We have because B is moving up, so in that case friction will be down the incline. It will be mu n, which is mu k into mg cos 37. Then we will have the acceleration of the block, deceleration in upward direction, so acceleration will be in downward direction. It's like this. So from this I can say mg sine 37 plus mu k into mg cos 37. This equals ma for block B. So acceleration of block B. So m cancels on both sides. So retardation in upward direction, acceleration in downward direction comes out to be g sine 37 plus mu g cos 37. So from this, let us find the value 10 into sine 37, which is 3 by 5, plus mu is 0.5 into g is 10 into cos 37 is 4 by 5. So on this, we'll get the calculation here. It comes out to be 2 meter per second square. So we have calculated the acceleration. This is down direction, but this is actually, this comes out to be 10 meter per second. So I did a mistake here. So it is 10 meter per second. Acceleration comes out to be 10 meter per second. So we can see the retardation up the incline is minus 10 meter per second in upward direction. Now, this is for block B. Let us do the same analysis for block A. So for block A, we have in this case mg sine 37 in downward direction for block A. This is the diagram down the incline. Friction in this case will act up the incline because tendency of motion of block is down the incline for A. Let us say its acceleration is A2. So mg sine 37 minus friction, which is mu k into mg cos 37. This is equal to mass into acceleration. So from this, mm cancels, and we get acceleration as g sine 37 minus mu k g cos 37, which comes out to be 2 meter per second square. So acceleration, this is in downward direction. Now let us calculate the relative. Let us use relative acceleration. So relative acceleration, in this case, acceleration of A with respect to B. So this comes out to be in this case, acceleration of A minus acceleration of B. Acceleration of A is 2 minus acceleration of B is acceleration of A is 2 in downward direction, so minus 2. Minus acceleration of B is minus 10. So our acceleration in this case will come out to be 8 meter per second square. So relative acceleration comes out to be 8 meter per second square. Now let us use relative kinematic equation. S relative is equal to U relative plus half A relative T square. S is UT plus half T square. So S in this case, we have to find S relative is 6, U relative is 10, because one block has initially 10 velocity, another is 0. It is released. So half into acceleration is 8 into time is t squared. So from this I will get the value of time. Time, it will come out to be 1 second. So in 1 second, what is the distance traveled by A block? So A block, let us use S is UT plus half AT squared plus A block. So S is half AT squared for A block. So S is half into acceleration of A is 2 into t square, which is 1 square. So it comes out to be 1. So acceleration of displacement of A block is 1 meter in down the inclined direction. So they collide at 1 meter from upward position. From A point, they collide at 1 meter distance. This is the answer to question number 19. This is how we solve illustration 19. Let us move on to next illustration, which is illustration 20. So in illustration 20, we have an insect. We are given like this. So insect is crawling up a bowl. So this is the insect. It is going up. So radius of this bowl is r. Coefficient of friction is given as mu. We have to find this maximum height up to which the insect can crawl. Let us try to calculate the value of this height. So first of all, at this position of the insect, there are various forces. One is normal reaction, N. We have one force which is mg. Then we have the component of mg along horizontal. So let us think about the angles here. So let us say this angle is theta. So this component here will be mg cos of 90 minus theta, which is mg sin theta. This is mg sin theta component. This is mg cos theta component. Sorry, I made a mistake. Not mg. This is n sin theta and n cos theta. So this angle is theta. Let us say. So this is n sin theta. So here we have one force which is n sin theta. Other than that, if I want to take the component of this is theta. So we can take the component of mg cos theta and mg sin theta as well, like this. So here, this is the direction of acceleration. Okay. So normal reaction comes out to be, in this case, equal to mg cos theta. Normal reaction is mg cos theta. Then we have friction force. Friction force will act opposite to motion. So friction force will be, motion is down the incline. So friction is like this. So friction is mg sin theta. So these are the two forces which we have here. If I call this equation 1, call this equation 2. 2 divided by 1. Equation 2 divided by equation 1. It will give us tan theta is equal to f by n, which is nothing but mu, because f is mu n. So nn cancels. So tan theta comes out to be mu. Now, in this case, we have to find the maximum height. So how will we find maximum height? So let us take this triangle. So this angle is theta. So this is r minus h, because this is h. So this total is r. So this is r minus h, and this is r. So tan theta from this triangle, tan theta is opposite upon adjacent. This is coming out to be, in this case, this is r square minus r minus h the whole square. So this side will come out to be root of hypotenuse square minus r minus h the whole square. So tan theta is opposite, which is this, upon hypotenuse, which is this. So tan theta comes out to be answer. So tan theta is root of 1 minus 1 plus h square minus 2h. So this is tan theta, which is root of 1 minus 1, which is 0, 2h minus h square. So this is root of 2h minus h square. So let us square both sides. So mu square is 2h minus h square. So now we have a quadratic equation in h. So on solving this quadratic equation, we'll get the value of h. We have to find the maximum height. So let us solve this quadratic equation. H square minus 2h plus mu square is equal to 0. This was our initial equation. So from this next equation, we get h is minus b square 2. So 2 cancels, 1 minus mu square. That is what we are left with. So based on this, we have to do these kind of calculations. Normal reaction is mg cos theta, friction force is mg sin theta, tan theta is mu. Then we have to find the value of h based on this value of tan theta is mu. So that is how we solve this question. Now after this, let us move on to next question. So here we have found the value of h. Now in next question, let us take next question, which is question number 21. So in question number 21, we have a diagram like this. And pulley here. And we have a string. Let us show the string in another color, brown color. So here we have two masses. Let us say one mass is this, and the mass is this one. So this is M2 mass, this is M1 mass. So in this case, this is the rough horizontal plane. Find the coefficient of friction. Mu value we have to find. Just sufficient to start the motion. That means acceleration is 0. So first of all, tension force here, M2G here. Acceleration is 0, given acceleration is 0. Friction force will be in backward direction, it will be kinetic friction, mu n. This is M1G, n is in upward direction. So friction force will be mu n, which is mu M1G. So for this, we have the diagram P is equal to M2G equation. For this, we have the equation P is equal to friction force in horizontal direction. So from this, we can equate these two equations. Let us say this is equation 1. Let us say this is equation 2. So friction force is equal to M2G from this equation 1 and 2. Now, friction force is mu n. Mu into M1G is equal to M2G. Gg cancels, and we get the value of mu as M2 upon M1. So our answer to this question comes out to be M2 upon M1. Quite an easy question. Question 22. Now we are given an inclined plane, something like this. A pulley here, a block here, a block here. This is M1, another one is M2. This angle here is theta. Normal reaction is N, let us say, M1G acts downward, M2G acts downward, tension force acts upward. Now, what is the question? Let us see. A block M1 is placed on rough inclined plane at angle theta with the horizontal. Another mass M2 hung from the incline. Just motion starts. That means acceleration is 0. Again. So again, let us think about the forces. So this is M1G cos theta because this angle is theta. This is M1G sin theta because the cross perpendicular component is sine. So let us equate these two forces and these two forces. So T is M2G. Here T is M1G sin theta. This is incorrect. We have to mark the friction force as well. This has a tendency to move down, so this will move up the incline. So friction will act up, down the incline. So tension force is equal to M1G sin theta plus mu n. So tension force here is M1G sin theta plus mu n, where n is M1G cos theta. So tension is M2G here. This is equation 2. Tension is M1G plus mu M1G cos theta. This is equation 1. Now if I equate 1 and 2, I will get M1G sin theta plus mu M1G cos theta. This equals M2G. So from this we'll get the value of mu, which we need to find. So mu will come out to be M2G minus M1G sin theta upon mu is on the lattice. So m1 g cos theta. So this is the value of mu which we need to find, which is the answer to this question 22. Now let us see question 23. So in question 23, we have a table. This is the table. We have a chain which we have kept on the table. Some part is hanging, let us say L dash. Some part is on the table. L minus L dash, if the total length is L. So in this case, we have to find the value of L dash. So that is, it is just stationary. So let us use the concept of linear mass density, lambda, which is n by L. So from this, we can say lambda is n by L. So m is lambda L. So mass of table part of the chain, chain on the table. So that is nothing but lambda into L minus L dash. Mass of the hanging chain. This is nothing but lambda L dash. Now, this force m dash or hanging part, let us say this is m dash and this is m. So m dash into g, the downward force, equals friction force, which is mu n, and this is mg. So normal reaction is n. So n is mg. So friction force is mu n. So friction force is mu into n, which is mg. So this is friction force, and this will be balanced by what, this downward force, which is m dash g. So what do we need to find in this case? We need to find L dash. So we have this equation, mu mg is equal to m dash g. This g cancels. So mu m, so lambda into L minus L dash is equal to lambda L dash. Lambda cancels on both sides. We get mu into L minus L dash is equal to L dash. So mu into L minus L dash is equal to L dash. So therefore mu L minus mu L dash is equal to L dash. So if I take this term on the other side, so L dash will come out to be mu L upon mu plus 1. So our answer to this question is hanging part is mu L upon mu plus 1 from this equation. So this is how we solve this question number 23. So I hope you understood all these questions up to 23 questions. So after this, we have next question, which is question 24. So we have various questions based on friction up to question number 36. Yes. So from 23, we move on to 24. So up to 36, we have questions all based on the topic of Newton's laws of motion with friction. So in this case, we have two blocks. One has mass 4 kg, another has mass 2 kg. Friction between 4 kg and incline is mu2. Friction between 2 kg and incline is mu1. This angle here is 30 degrees. So now in this case, mu2 and mu1 are given to us. Mu1 is 0.2. Mu2 in this case is 0.3. Mu1 and mu2 are given to us. So we have to find the acceleration of 2 kg block. So we have to find acceleration of 2 kg block. So let us first think about the forces. If I consider these two blocks as a system, so 4 plus 2, which is 6. So 6 kg into g sine 30. That will be 6g sine 30, downward force. mg sine theta, like that. 6g sine 30 is the downward force. Now, other than this, because the tendency of motion is downward, friction will act in upward direction. And it will be static friction. Let us find maximum value if it is static friction. So that is mu s into n. So n here is normal reaction, which is m1 plus m2 into g cos 37. Cos 37. Because we are increasing this 30. So this is the maximum value of static friction. So in this case, mu is different for two masses. Let us use different value here. Mu1 m1 plus mu2 m2. That way we will have to write. This will be mu1 m1 plus mu2 m2. Like this. This is the maximum value of static friction. Now, the net force, it will come out to be what? M1 plus M2 into G sine 30, downward direction, minus mu into M1 plus mu M1, sorry, mu1 M1, because we have different frictions. Mu1 M1 plus mu2 M2 into G cos 30. So this is the force, net force. So let us calculate the value. M1 is 4, M2 is 2, G is 10, sine 30 is half. Mu1 in this case is given. So mu1 is for 4 kg block, which is 0.2. So M1 I have taken. You can take any one. So let us take mu1 as 0.2 into M1 plus mu2 is 0.3 into M2 into G cos 30, which is sine 60, which is root 3 by 2. So like this. So this is the value of applied force. So on calculation, this will come out to be 30 minus 13.76. Let us do that calculation as homework. So this will come out to be 16.24 Newton. So from this, acceleration is force upon total mass. So force is 16.24 upon total mass is 2 plus 4, which is 6. So it comes out to be 2.7 meter per second square. So this is how we solve question number 24. So moving on to our next question, which is